just so you're all aware, so I'm just starting the recording. Some of you haven't muted your mics yet. If you could just do that, that would be great, because I get a little bit of feedback, so thank you for that. I'll go through, for those of you who've just arrived, I'll go through all the circle theories, because that's what we're going to look at. Today. I am recording this, so just don't stress if you haven't had a chance to keep up. Just wait for it to upload onto Teams, and when I get an opportunity, I will upload it onto YouTube, because I think Teams is working quite slowly, whereas YouTube's obviously a very system. So once it's on YouTube, it's a lot easier to. They definitely play a lot quicker. The other benefit of YouTube, I'm finding, is that all the videos are filed together. So once you find the place where it is on my YouTube channel, if you've missed a lesson, you can just see them all in a row. So welcome back, everybody. So if you just want to make some notes, we're going to be looking at circle theory today, 28.1. You'll see at the top that I popped it down as being today's lesson and tomorrow's lesson. Okay, so we'll do the live bit today, which I think will take about 15 minutes, and then you'll have whatever time you want to do for the rest of the lesson today and tomorrow's lesson. You can be working through the worksheet. It's a Corbett Maths worksheet. You'll see that I've given you both the worksheet and the answers. Okay, so they're available either on Show My Homework, or also I've just attached them on Teams. So you might have seen as you were just logging on that they're there as attachments. So there's a couple of attachments for you there. Okay. The other reason I want to give us a couple of lessons on this is that I really want you to get comfortable with uploading onto Teams via the assignment method. So it will take a bit of getting used to, but once you're there, it's going to make things so much easier, because basically I can see, just looking at a single sheet, who's handed it in, who hasn't, and I can then, it's very easy for me then just to leave comments and to give you a mark and so on. So I think going forward, while we're still working at home, doing it through assignments is going to be excellent. So I want to give you a bit of time. Now, you've probably seen from Mr. Smith and the headmaster over the holidays a bit of refinement to the remote working policy. We do appreciate that it takes a long time to upload stuff, and all the computer stuff takes time. So what's being said is that each lesson should really kick off with about a 10-minute sort of chit chat, perhaps. It doesn't have to, but that's my plan. But really, the key bit is you should only really be having about 25 minutes compulsory work. So I will make sure when I start giving you marks that I'm only really allocating a mark for about 25 minutes worth of work. Okay, so you don't have to feel that you've got to work all the way through a worksheet in order to get a good mark. I will be realistic. If you've done a good amount, if you're getting the ones right that you've done, I will really just sort of be giving you 100% on those. And I'm not really that bothered about the marks per se. That's why I'm giving you the answers as you go. I just want you to be able to feel that you're understanding it, so you can mark the work as you go. We'll come back to it a bit later, but it would be great, really, if you can download the worksheet, do your answers, mark it, and then upload it marked. And that obviously saves me the effort of having to mark it. But what I'm really keen to do is to make sure that I review your work and leave you comments and give you some constructive advice if you are making mistakes. So that's really my ideal. So anyway, on to today's lesson. So that's really what we're going to be filling in. So some of you may have had the opportunity to produce that sheet to run that sheet off. If not, don't worry. All right, just literally just draw some circles by freehand, and then you can just tidy up your notes afterwards. Okay, so there are what I consider to be 5 fundamental circle theories. So that's really why I want to get the 5 looked at first. There are others which we will add to, but there's really the big 5, which are pretty straightforward. And the worksheet today really kicks off, the start of the worksheet is really focusing on these 5. Okay, So what we're going to do, we're just going to really fill in these 5 circle theories. So the first one, if you've got a tangent to a circle, the tangent just means the line that skims the circle, so it just touches it at one point, so clearly this is a tangent. By definition, if you take that tangent and where it touches the circle, if you then just from that point draw the radius to the center of the circle, by definition this angle is 90 degrees. Now, with circle theory questions, some of the marks are going to be for working out angles, but half the marks are going to be for justifying your answers. So there's going to be lots of times they say give a reason. Now we've got to be very precise with the wordings that we give, but equally I don't want to make it too verbose or too long. So the wording that I'm giving you here is sufficient to get full marks. Okay. Now you may read other places sort of more technical wording or posher wording if you like, but I promise you that the wording that I'll be giving you, if you can just remember this, it's accurate enough to give you full marks. So if you were having to justify this being 90 degrees, you would just simply say the angle between a tangent and radius is 90 degrees. So that's circle theory 1. By the way, this is not, there are 5 of them. They don't have a particular number. Okay, so don't ever say and circle theory 1 is blah blah blah. This is just the first one we've looked at. They don't have numbers. Okay, now the second one we're looking at, this is when you are involving a semicircle, and so you are involving the question has the diameter of the circle. So look out for questions where the diameter is being included. Because if you've got a line through the center of the circle, so a diameter, by definition, if you go from the 2 ends of that diameter and you bounce off the circle anywhere you like, by definition, that angle is 90 degrees. Okay? And the reason you would give, if you were just having to justify why this was 90 degrees, you would just simply write down the angle in a semicircle is 90 degrees. And of course it would work down here as well. These would all be 90 degrees. So that's the second theory that we need to learn. Now, the third one. What I want you to draw here, please, is a quadrilateral inside the circle where all 4 corners, all 4 vertices are touching the circle. And just for your notes, can you try and make it not look like a rectangle and not look like a square? Because it works for any quadrilateral. Now, as we know for any quadrilateral, the angles inside it total 360 degrees. So that's nothing new. That's not the circle theory. Where you've got one of these quadrilaterals, and it's called a cyclic or cyclic quadrilateral, that's spelled C-Y-C-L-I-C. So where you've got a quadrilateral where all 4 points touch a circle, as well as all 4 angles adding up to 360, it has another property. The opposite angles themselves total 180. So if you happen to know that W was 100, then Y must be 80. Okay, so W and Y added together are 180, and X and Z added together are 180. Now, how would you justify that? What reason would you give? You would say opposite angles in a cyclic quadrilateral total 180 degrees. So that is the third one we've looked at. Opposite angles in a cyclic or cyclic quadrilateral total 180 degrees. Now, the fourth one. So what I want you to do here, please, can you go and draw a dotted line going, so a chord of the circle, it's a chord, but don't make it look like a diameter. It's not a diameter. It doesn't have to be a diameter. So just go and draw a dotted line sort of below halfway, so below a diameter, but equally just don't make it right at the bottom, so somewhere like that. Now, this is a good opportunity just to remind ourselves of some of the wording. Obviously, a line going through the circle from one side to the other through the center is called a diameter. Where we've got any line going from part of the circle to another part, that's called a chord, C-H-O-R-D. So that is a chord. Now, when you have a chord, this creates two areas. It creates an area above the chord and an area below the chord. Now, each of these are called segments. Now, not that it's relevant here, but it crops up later and certainly at A level. The smaller segment is called the minor segment, and the larger segment is called the major segment, but that's not relevant here. Now, what we have here, if you come off from the two ends of the chord and you bounce off the circle, so you go from A, bounce off the circle down to B, that creates an angle which we will call X. But also, if you go from A and somewhere else in the same segment and bounce off the circle and go down, that will also be X. So anywhere we go up here, where we go A, bounce off the circle down to B, all those angles that are being created will be the same. So what reason do we give here? Well, we just say the angles at the circumference are the same. The angles at the circumference. Here's an angle and we're at the circumference. However, this is the one circle theory where we do have to be really precise. We've got to go and say comma in the same segment. Now that's because all the angles above this line, they're all going to be X. Absolutely, they are all X, no problem. However, if you start bouncing down here, so you go A down to here and up to B, and A down to here and up to B, they're all going to be the same, but they're going to be a different angle. Okay, you can see they're all going to be bigger angles, aren't they? They're going to be bigger angles. So they're all going to be the same down here, A to the circle to B, A to the circle to B. They're all going to be the same in that segment. So this is the one where you've got to put in that comma and then be really precise and make it clear that it's in the same segment. So circle theory 4, the fourth one we've looked at, the angles at the circumference are the same, comma, in the same segment. So that's our fourth one. Now, our fifth one. So, what I want you to do here, please, go and take points A and B, a bit like with the previous one. So just have them sort of not forming a diameter, just have them sort of nicely apart like that. Now, what we're going to do, we're going to go from A to the circumference and down to B, and we're going to call that angle X. And we're going to go from A to the origin, to the center of the circle, and down to B. Now, that angle, by definition, is twice as big as the angle at the circumference. Okay, so it's just another one you've got to learn. So, and what reason would you give? You'd say the angle at the center is twice the angle at the circumference. So try and give the reason the way it's actually worked in the question that you've answered. So if you were given that X was 30 and you've concluded that this angle here is 60, because you've gone from this one to this one, you'd want to set like I've said it here. The angle at the center is twice the angle of the circumference. Of course, the question could be the other way around. They could have given you this angle here and you were working out this angle here. Say this was 100 and you've gone and worked out that this was 50. In that case, just give the reason the way around that you've done it. Just say the angle at the circumference is half the angle at the center. Now, be careful with these. I think it's quite easy to spot when this angle at the circumference is nicely up here. It's sort of creating a bit like a sort of Star Trek badge. I don't know if you've ever seen Star Trek. But obviously the origin is fixed. But this point here can be anywhere. It could be here, it could be here, it could be here, it could be here. Now, obviously, as it starts moving around, it sort of becomes like this shape down here, okay? We're still going from A to the origin down to B, but once this point here moves around to here, now that's gone over here, it's a lot harder to spot, okay? But that angle there at the origin is still 2x, and that angle here is still x. So don't think it's only going to occur when this angle at the circumference is nicely above here. There's no reason at all that it can't be anywhere all the way around to B. Now, for IGCSE, which is the exam that you guys are probably going to take, 99% certain we will stick with that, you don't need to prove any of these circle theories. You do with the GCSE. However, I think a couple of them are just nice to be able to see how they work. It's nice, and it just sort of firms up your knowledge, your understanding. So I would like us to work through a couple of the proofs. Now I'm going to do this quite quickly now, because I don't want to make this video too long. But what I would like you to do, once the videos have uploaded, this recording is uploaded, I'd like you to go back and just go through these again slowly in your own time. So I've just picked out a couple of them here, because I think a couple of them are really nice. So this is going back to our second circle theory, where we were saying the angle in a semicircle is 90 degrees. So why is that the case? Well, look, if you go and draw a line from the center of the circle up to where you're hitting the circumference, can you see that we've got two isosceles triangles? This triangle over here, let's call this ABC. Obviously that's a radius, and that's a radius. So these two angles here are the base angles of that triangle. So let's go and call those two angles x. Okay, so I've got that from triangle ABC. AC and BC are radiuses, so they are equal length. So ABC is an isosceles. So both those angles there, excuse me, are x. Similarly, when we go over to this little triangle here, BCD, that length there is a radius, that length there is a radius. So we have that BCD is also an isosceles triangle. So its base angles are equal. They're not going to be the same angles, unless B happens to be straight upwards. But they're going to be the same angles. So let's call those angles Y. Now, what do we know about angles in a triangle? They add up to 180. So looking at the big triangle, ABD, all those angles together have to add up to 180. So x plus y must be 180. So 2x plus 2y is 180. Divide that by 2, we get x plus y equaling 90. And there we go. That's an x plus a y. So that's why that's 90 degrees. So that's a nice proof. So I don't expect you've had a chance to fully digest that yet. So that will be one of the things I want you to do when the recording finishes. The other one I think is very nice was that circle theory 5. Now this one's a bit more complicated. Okay, so we'll start off by drawing your Star Trek shape. And we really start off with the same sort of idea. We've got two isosceles triangles here, haven't we? That's a radius, that's a radius. So these two base angles are the same, so let's call those A. And similarly, this triangle over here, that's a radius, that's a radius. So that's another isosceles triangle. Let's call both of those base angles B. And then let's just give all the others names. So let's call that C, D, and E. Now, what do we know about angle C? Well, the angles in this triangle must add up to 180. So C must be 180, take away A, so 180, take away 2A. Similarly with D, that's in a triangle where B plus D must equal 180. So D is going to be 180, take away 2B. So there's two facts. Let's just park those. Now, what do we know about E? Well, angles about a point add up to 360, don't they? So E plus C plus D must be 360. So, or in other words, E equals 360, take away C, take away D. So E equals 360, take away C, take away D. But we've just worked out that C is 180, take away 2A. So we're minusing C, we're minusing 180 minus 2A. And when we're minusing D, well, we're minusing this. We're minusing 180 minus 2B. So we've got 360 minus C minus D. Now you then just need to be very careful with your clause. This is 360 minus 180, but we're minusing a minus 2A, which is adding a 2A. So this is 360 minus 180, add 2A. And then over here, we're minusing 180, but minus times minus 2B is plus 2B. So overall, what we've got is 360 minus 180, add 2A, minus 180, add 2B. The 360 minus 180 disappears, leaving us with 2A plus 2B. So if we factorize that, we get 2AB. So we've worked out that angle E is 2 lots of AB. This angle here is 2 lots of AB. Well, AB is this angle at the circumference. We've just proven that the angle at the center is 2 lots of that angle. So I think they're nice proofs. They're very satisfying when you see them. It's nothing that we haven't done before. It's just basically using our knowledge of isosceles triangles, angles in a triangle, angles about a point. So I would like you, please, when this lesson finishes, just to work through those again and see if you can just sort of do those from first principles. Again, as I said, I think it's more just for the satisfaction of being able to do it. My understanding is that it is not part of the IGCSE syllabus as things stand. Now, there are a couple of other circle theories that one other I think I've done today. One other one it's not one of the big 5, but it's another one that is applicable, but this is sort of more outside the circle. If we've got a couple of tangents here, going to a point, so we've got a point here, so we do a tangent to a circle and a tangent to a circle. Well, from our circle theory number 1, we know that the angle between a tangent and a radius is 90 degrees, so that's degrees. And similarly over here, tangent and a radius, that's going to be 90 degrees. Now let's go and call this angle here x. Okay. So what we know is the tangents to a circle from an external point are equal in length to the point of contact. What we're saying there is this length here must be the same as this length here. And we can see that they must be because they've got this, the radius is a common side. Okay, they've both got the radius in common and they've got their angles in common. They've both got a 90 degrees. They've both got an x. So these would both be a y. So they're similar triangles. They've all got the same angles, but so yes, they've all got the same angles. So but the fact that they've got this length in common means that they are congruent triangles. So they're not just similar. They're not just got the same angles. They are congruent triangles because not only do they have the angles in common, they have a side with radius in common. So by definition, therefore, that length must equal that length. And then the other thing that obviously flows from this, because this is x and this is x, that length there, by definition, is bisecting the quadrilateral because we've got 2 x's. So if you could just work through that one as well, that would be good. Okay, now, just before I go, I just want you to talk you through the advancement we figured out with regard to teams. Okay, you will have seen from what we were doing before before Easter break that you are able to upload things into your class notebook. Okay, but what's better, we found a way that we can actually put the work in there ready for you, and then you just attach your answers to it, and we do that via assignments. So this is an example. Okay, this is a different year group, but when you go in, if you go and look under homework, you will find that there should be waiting for you already when you go up here it will be saying 18.1 circle theory. So when this lesson is finished, just go and check. Go into your Teams, go into your homework page. I'm not putting it under class notes, I'm putting it under homework. And you will see that you've got an 18.1 circle theory, hopefully already waiting for you here. Now, when you click on that, this page will come up, okay? And you will have the worksheet waiting for you already, okay? Now, obviously, that's not where you download it from. You download the worksheet from either Show My Homework or from the other part of Teams where we just had the dialogue earlier on. It's called Notes, I forget what it's called. The one where we just sort of exchanged messages and I told you when the lesson was about to start. I've also gone and uploaded the resources there. Now, if you go and click on this, you will see that below it, I have included a box ready for you to insert your answers. So when you've done the work, all right, so you download the resource, you go and do 25 minutes of work. Obviously, this particular one would be more because we've got today's lesson and tomorrow's lesson. But when you've finished your work, please mark it on this occasion because I've given the answers. This is where you will upload it. So you will click on this box. When you click on this box, this file and this picture option will become available to you. Okay. Now, obviously, you've just taken pictures on your camera. You go down the picture route. But if you're scanning your work and uploading, so going down the file option, please make sure you go for the insert file printout option. Okay, not insert as attachment. That will mean when you upload your answers here, it's dead easy for me just to mark on the screen, please. Now, when you've done that, I want you then also just to find where the option is to go and say that you've handed it in. So I can't exactly remember how you do that. Obviously, not being a student myself, I can't see it from your point of view. But there's a way that you can, through the assignments, go and click that once you've actually done the work, you've gone and clicked on that and uploaded it, you can go and click the handed in option. And then this is an example of what it looks like from my point of view. So this is my first form. So I can see that Cecily and others have actually clicked the handed in button. So please don't actually go and click that button until you've actually uploaded the work. But what I'm finding is you'll see a lot of these first formers have viewed it, but so I think they probably uploaded it, but they haven't then gone and clicked the handed in option. So as I said, I'm a bit vague on where the handed in button lies for you guys. You'll just have to have a bit of a look around. And then maybe what would be really good thinking about it, when one of you discovers how to do that, if you could just actually post that in notes so we can all see it, you can all help each other along a bit there, please. But it's then great because I can then basically just click on each of these, your work comes up, I can go and remark it, look at it, I can leave a comment, I can leave a mark, that then automatically goes into my mark book and it's excellent. Okay, so to conclude, all right, I've set the assignment in Corbett Math, the Corbett Maths assignment. So 2 places you can download it from, either Show My Homework or from the notes on Teams. Any time, I know I've been going on a lot today, but time remaining in this lesson, you can make a start on those questions and copy up your notes and work through the 2 proofs. And then we've got tomorrow's lesson where you can really be trying to work through that worksheet to a degree. Now, it does get tricky later on, okay? So please don't start stressing. There's absolutely no obligation for you to complete it. I certainly don't want you to do. I know some of you, really find it difficult not to do the whole lot. It does get very difficult later on, okay? So please just spend a sensible amount of time on it, focusing on those earlier questions. It will not affect the mark that I give you. I'm going to do the mark based on the opening questions. Right, that's it. So I'm going to go and stop the recording in a sec. So let me do, oh God, please say it's recorded. It would be a disaster if it hasn't recorded. Right, stop recording, excellent. Okay, so I'm going to say stop recording.